So here we're going to do something that is a very foundational unit. And we've already been doing some, and we're going to look at factoring. Now, factoring, I don't know if you guys even remember doing these, but you used to have to take 20. And 20 was like, okay, yeah, 2 times 10. All right, then you had to go and 2, and this was 2 times 5. Do you remember doing those? Factor trees? Fun, hey? Okay, that's what I was looking, what those look for is, what is 10 made up of? And what are 2, 2, 5? What are those numbers called? 7, 11, 13, 17. What are those numbers called? Prime numbers. These will always be prime numbers, meaning you can't factor them anymore. That's all you're doing here. But you know what? They're throwing X's and Y's and all this stuff in. And what this does is when you learn how to factor, okay, as you'll see, you learn how to do kind of 2 things at one time. Whenever you go to find, well, I need 2 things that add to give me this, and those 2 things have to multiply to give me this, what you're trying to do is you're trying to serve 2 things at one time, and you have to make them both happy. Okay? Now, that's a big part of if you're ever going to be a manager. Okay? I can tell you, if you're a good manager, you'd be really good at factoring trinomials. Okay? Because a manager has to have like 10, 20 things all going copacetic at one time. Okay? And it's a good day when you got it all done. It's a good day when you got those guys working, they got that project done. These guys, you got them getting along. This customer, you finally got him calmed down after those 2 guys did a crappy job, you know, blah, blah, blah. Right? And that's why if you're a manager, A, you have to have thick skin, right? And B, you always have to think of all the different factors. That's why they call them factors. And make a decision. Okay? This is what teaches it to you. Honestly, this is the logic part. This is like neural pathways that are created. I don't know if I've ever done factoring like in my regular day. Specific factoring like this. Never. Okay? I do it at school, obviously, with you guys, but never like outside of school. But I have to consider a lot of factors to do a lot of different things in my life. Okay? So, and that's what, you know, that's what helps me to be able to do this. Now, when we're factoring, there is one thing that is so important that I cannot say it enough, and it's this right here. Before you start any question, see if you can take out a common factor. I'll tell you, this step gets overlooked more than any other step and causes huge problems. Now, what it causes is a simple question to be made gigantic and a lot of work. And you can still get the right answer when they're gigantic and a lot of work, but if I was writing a test and I took out the factor and then it's a 10-second question, or I didn't take out a factor and it's a 2-minute question, or maybe a 3-minute question. 3 minutes, you're like, that's no big deal, man, 3 minutes. But you know, like on a test, you're given an average of about 2 minutes a question. If you get one question done in 10 seconds, you can see you've bought yourself some time. And you know, there's the saying that it's always the rich that get richer. Well, it's actually the ones that study more get more time to look over their test at the end. Because if you study more, you're faster. If you're faster, you get done quicker. You get done quicker, you can go over your test a few more times, right? So it's like the more you know, the better the mark you get. And the rich get richer, that sounds unfair, but the more you know, the better mark you get. That's like, well, that's cool. Like, I don't get where that's a problem. Okay? Well, why do the rich get richer? Okay? Well, when you're rich, you got all this money. You can invest in this stuff, and then it makes you more money. When you go to the Oscars, do you know that every single star gets this like little bag. They always come home with a bag, and the bag averages about $80,000 each. There's all this stuff in there. It's free. Here you go, free. And when you have lots of money, like Michael Jordan's probably never bought a pair of shoes like in the last 20 years, right? I mean, they just give him shoes, right? The guy's got billions of dollars, and they still give him everything, okay? And it's like, what? He's got all this money, and he still gets free stuff. I have no money, and I have to pay for everything, right? You know, it's just like, well, you know, that guy's always able to check over his test. You know, he knows his stuff and then because of it, he gets a better mark. And most people go, yeah, that makes sense. Okay? So this step right here, I'll tell you, it saves you a lot of grief. Now, all of us, including me, will overlook this every so often and be in a world of hurt trying to figure it out. Okay? So there's nothing more important than that step, and even though I've said this, probably 25% of you just ignored me or will forget, and will still not do this step. Difference of squares, factoring trinomials by inspection, and factoring by grouping. Okay? Now, this is what we call, this is like type 1, and this is what I call like type 2 polynomials. Okay? We'll talk about that. But let's just talk about taking out or removing a common factor. Like you look at A. What's a common factor I can take out of both of those? Now you got to take as much as possible. So 5x squared, leaving you with x, 3x I should say, minus 1. And as a quick check, I would factor it back in and see if I get the question. I'd multiply it back in, right? What's another way to guarantee that I'm done? Anyone know? Guaranteed that's the right answer. Plot both forms in your calculator. Now, here's what, I did this with the last class, and one student goes, I wish I would have known that earlier, okay? Because I'm going to show you a trick on the calculator. So if you go to, let's all hit zoom 6, because I want everybody to be in the same, but put the question and put the answer into your calculator, okay? Now, here's the secret. Go over on the left side and hit enter again, and it'll give you the thick black line. Because to know if I got these right, they should give the identical graph, right? But how do I know if they're both like the same line? How do I know one's on top of the other, or one gave me the graph and the other's kind of way, way, way off the grid? I don't know if they actually worked out. Okay, because someone in the other class said, well, you know you got it wrong if you got two graphs. But one graph's not going to show up with the other graph if they're both wrong. So if you do that, and don't graph it yet, but I'll show you a trick to be able to, because sometimes this graph is not going to be in your nice little grid that you have, the 10 by 10. So what do? How do you find it? Okay, so the way you find it is by hitting the zoom button. Okay, everyone hit zoom. And you go down, and it's this one. It's called zoom fit, or 0. So you can press enter now, or 0. Okay, it's thinking. And what it'll do, and it gave me a totally different graph last time, but it'll always find it for you. And you see how the thick one's going over the thin one after? You might not even get the same zoom fit as me, but it will get you, it'll show you the graph. Now, this is a good way to verify. Now, your calculator will not get you the answers. It'll tell you if you're not right or if you are right. Okay? Because you guys have to be able to, on the diploma, be able to try and prove every single one is right to yourself. You will walk out of the diploma and you will know how many you got wrong for sure. Okay? You'll say this to me. You'll go, well, there's 2 I know I have wrong, and there was another 2 that I don't know for sure. So we talk about it, and then you know exactly which ones you got wrong. What happens after the diploma is everybody stays in the atrium down there, and they all talk about the test for about 15 to half an hour. So everybody marks their exam with other people. Okay? So if you got something like this and you're like, I graphed it and I did this and I did this, I know I got that one right. Right? That's the first thing students are going to say. So as we're going through grade 11 and grade 12, I need you to always be thinking, how can I check this over? Now, when you're doing your homework and maybe you're doing, 50 questions, you're going to check each one over. But when it's an exam, it's kind of worth some marks, right? Yeah, okay. Now, let's go to example 2. Now, these are called difference of squares. Now, I don't know if you know what a difference of squares is, but a difference of squares is a squared minus b squared. It must be in that form. That means the first number is a perfect square and the second number is perfect square, and it always must be separated by a minus. Does everybody know what difference means? Nope. In mathematics, what does difference always mean? Subtraction, minus. Okay? So this will always equal a plus b, a minus b. Okay? Now, how am I going to, like what? How do you know that? Is that just some trick I got to learn? Okay, well watch. First of all, there is no middle term. Do you notice that? Well, let's FOIL this. If you FOIL this, you get a squared minus ab. Okay, this is plus ab. And then minus b squared. You see where the minus ab and the plus ab cancel? Leaving you with a squared minus b squared. So that's proof to you that a squared minus b squared is a plus b, a minus b. Now you can't do this unless a and b are perfect squares. And you can't do this unless there's a subtraction sign. Okay? So, what would a be? X minus 9, x plus 9. Okay? Let's just skip B. Let's do C. What would C be? 3x. Would this give me the above one? Would it? Not possible, right? Okay, what's D? 4t minus 8, 4t plus 8. Right? Put a big X through that, because it's not right. What does that red box say? Is there anything I can take out first? Better not. 16, that would be t squared minus 4. So the answer would be 16 t minus 2 t plus 2. Okay, so there's one just baiting you. Please don't factor me. Please don't factor me. Just go, or don't take out a common factor. Just do perfect squares on me. You see how, oh, come on, 16. 16 is a nice perfect square. You guys know that. I mean, you're probably still having nightmares about those perfect squares and cubes. And then 64. Oh, no, 64. Look, and a minus sign. Nice. Okay, and then you get her down, and you're just like, giving yourself a pat on the back, how awesome you are, moving on to the next question. But you didn't do the one thing that you should always do before you start these questions, and that's factor it. And you see how A couldn't have taken out anything. C couldn't have taken out anything, could you? Okay, but D, we were doing perfect squares. Here's another perfect square, right? Okay, now here is trinomials by inspection. Okay, so we're going to call this type 1. Now, there's some people that are really, 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 really good at these, and some people are really, 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 really bad at these. Okay, so I'm going to give you steps to be able to do these that the really, 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 really good students will maybe not need, but the ones that are really, really, really bad at these will get that. And now, what you always have to do, it's what two things add to give me positive 11, and what two things to multiply to give me positive 30. Now, you need to do this in two separate things. The first thing I need to know is what will be the signs of these two numbers. Guaranteed, no ifs, ands, or buts. This will be the signs of them. What will they be? Huh? What will be the signs? Positive. Why? Because only two positives add to give you a positive. Right? And only two positives multiply to give you a positive. So I look at the second number first, the positive. There's only two options. Right? We know that there's only two options to get this. A negative times a negative or a positive times a positive. Can a negative plus a negative ever equal positive? No. So you know that the two numbers are positive. So actually tackle that first. Because even my top students don't do that, and they mess these up once in a while. And you know when they mess them up? On an exam. They won't mess them up on their homework. They won't mess them up on a quiz. They'll do it on their exam. Because they take for granted they're above this stuff. Okay? Now, do you know there's actually about 60 gazillion numbers that add together to give me the answer 11? Okay? But there is only a few numbers that multiply to give me 30. There's 1 times 30, there's 2 times 15, there's 3 times 10, and 5 times 6. That's it. Okay? So go through the factors of 30. 1 plus 30, no. 2 plus 15, no. 5 plus 6, yep. Okay? So 5 plus 6 and 5 times 6. And then it's just A plus 5, A plus 6. So always do the signs first. Then do the numbers that multiply to 30 and see if they fit into the 11. Okay? I'm not into doing B's today, so let's do C. Okay, so I'm looking what two numbers give me, when I add them, give me negative 4. And when I multiply, give me positive 48. So guaranteed, what are the signs? Double negative. No other option. Two positives will never give me negative 4. Not in this lifetime. So they're off. I'm going to try my two negatives. So I'm looking for a negative and then times a negative that equal positive 4 when I add them. So yeah, you have to be thinking two different things at one time. Okay? Now this stretches the brain a bit, right? You got to satisfy two equations when you do this. And what are the two numbers? Nobody? That's not possible. If you guys can't get it, nobody can. Okay, D. How is D different? Common factor. But most people look at this and go, oh, that's one of those ones where there's a number in the front, right? What's a common factor? First, 3x. That takes me to x squared minus 7x plus 12. Okay, then I'm looking for two things that add to give me negative 7 and multiply to give me positive 12. So what are the signs for sure? Two negatives. And they are 3 and 4. So this is 3x, x minus 3, x minus 4. It's bringing back a few memories. Good ones, I hope. Sitting by the fire, you and your dog cuddled up together doing some factoring. Mom coming by with hot chocolate. So everyone got that in their head? Okay. Factor by grouping. Now, this is kind of a, I don't like how this is, so we're going to actually put the question above this one, because it was kind of, this was 6y squared plus 11y plus 3. Now, this is what I would call a type 2. It's a type 2 because there's a number in front of the x squared and it can't be factored out. Don't get that mixed up with the one right above it. The one right above it was not a type 2. It did not have a number in front of the x squared because it was factored out. When you're doing type 2, type 2, type 2, and you've done 3 or 4 of them, you will forget to take out the common factor after a while, and they're going to catch you. Okay? Because you're going to get the wrong answer. It's not going to be simplified enough. So this is a type 2. In this one, I am looking for two things that add to give me 11 and positive 11, I should put, because remember, we want to deal with the signs first, and two things that multiply to give me come on, 18. Remember that? You have to take a times that too. Okay? What would be the signs? Two positives. So two positives that add to give me 11. No, 4 and 6 is 10. 2 and 9. Or 9 and 2. Now remember these. You just don't get to go, 6y or y minus 9, or y plus 9, y plus 2. You've got to take it and put it this way next. So that's why I didn't like the fact that that was the question, because they did too much work for you. But that's how you get to that stage. Okay? That's 6y squared plus 9y plus 2y. So you actually take the 11 and split it up after you've done that. So that's how type 2 is different. Then you put brackets around the first two, and don't take the positive, and then the next two with the positive there. Now the question I get all the time when I teach these for the first time is, well, what if you would have put 2y plus 9y? Won't you get a different answer? Nope. Okay? Even if you take the 2y, 9y, switch, you'll get the same answer. Promise. Now you look at the first set of brackets. Is there anything I could take out of there? Take out what? 3y, leaving you with 2y plus 3. In the second set, remember, you got to take something out. When in doubt, take out a 1. Okay? And you know that you've done them right when both sets of brackets are the same. And you know that you're totally lost when they are very different. Now, both of them have a 2y plus 3 in them. So I will factor that out, 2y plus 3. And that will leave me with the 3y plus 1. Okay, so the next page kind of gives you the rundown in words if you want your, but the flow chart's kind of nice. This one's at the very, very top, okay? If I could make it where little fireworks were coming out of it, that would be awesome, because that's what you need. It's almost like you need this little thing sitting on your shoulder when you're doing your test going, make sure you factor out first. Every question, make sure you factor out first. I love it when students put that on their study sheet, just big, bold, highlighted, asterisks everywhere, take out a common factor first, because there's a few, but if you don't do this, you take about 5-6 minutes to do the question, right? And it's a really easy question if you take out a factor first. It is the meanest, longest question if you don't. And you'll see them as you get going, how they like to pop up, okay? And then at the end, check and see if there's further factoring, because sometimes there will be. Here's a case where this would happen, okay? If you had x to the 4 minus 16, okay? So this would be x squared plus 4, x squared minus 4. And some people stop here, but do you see there's another perfect square left? You can't do x squared plus 4, but you can take, so this is going to stay there, and this would be x plus 2, x minus 2. Okay? So even at the end, check, can I go more? Yep. Because there's no 2, remember, I would come up with middles, right? It's got to be the difference of squares. Difference being the minus sign. Because x plus, that can't, like, you can't actually come up with one that would work. Okay, so there's an example of make sure you factor even at the end. Okay, this one here. What would be the answer? People get all freaked out when the x squared is second. Are they still perfect squares though? Okay, so what's the answer? Take out 3 first. Oh, I didn't catch Isaiah. Ruined my fun, Isaiah. How many of you would have thought to take, come on, they're nice perfect squares. See how they just suck you in? It's like the devil question. It just sucks you in, you don't even know what's going on. Next thing you know, you get the question wrong. Is that as good as I could have done? No. So you should have factored out a 9. 4 minus x squared. Is that difference of squares still? Yep. 9, that would be 2 minus x, 2 plus x. Okay. B, I don't like it like that. Okay. So what you can do is you can take out a negative, right? That'd be negative 28 minus 3x plus x squared. So why did I take out a negative? Just because I like doing extra steps? No, actually, believe it or not, I don't like doing extra steps. But then it makes it look like this. If I change the, get in the right order, x squared, oops, it's supposed to be at 28, minus 3x plus or minus 28. Okay, so I took out a negative, so there wasn't a negative in front of the x squared. Put it in the right order. Now, I'm looking for 2 things that add to give me negative 3 and multiply to give me negative 28. Now, I used to teach these when I got students coming right to me and they've never seen this stuff before, right? So I would teach them this. Students that have trouble with integers, I would teach them this cowboy story. And You got your positive cowboy and your negative cowboy, and they hate each other, so they always fight, and the one with the more bullets always wins, and he wins by the number of bullets he has, right? So you got positive 9, he meets negative 2. The positive cowboy would win by 7 bullets, okay? So that's how you would get your answer. Now, so this one, I would go, okay, first of all, what are my signs? What are my signs going to be for sure? Positive and a negative. Now, this is where I would disagree with you. I would say they're a negative and a positive. Why? Because a negative cowboy wins. Do you see that? So the negative is the bigger number. Does everyone see that? Okay? So I would be very deliberate with my students because what am I trying to do? I'm trying to get them to achieve perfection, obviously. So you know what does that? It's doing the same thing over and over and over. The same. Okay? So I wouldn't say put a positive and negative. I would say put a negative and a positive. And someone would argue that's the same thing, but it's not. Because we always want to put the bigger one first. So my two factors, what times what equals 28? Negative 7 and positive 4. Now you see how it shows, hey, oh yeah, okay. So the winner always goes first. And I can verify that quite easily. So then this would be negative x minus 7, x plus 4. So when you do factoring, okay, it definitely changes and adds neural pathways in your brain that you think differently. Okay? Will you actually ever have to factor these in real life? No. Will you ever have to look at a bunch of factors and try to make them all work? Yep, you will. Okay? No matter what job you're in, high or low, okay, you're going to always have to be able to take all the factors and make them work. Okay, so we're going to do 1 to 12 and just do the A, C, E's for those that have. So it's pretty quick. You guys have tons of time. You have half hour. And I have officially finished all my taping.